Welcome to this video on the properties of rational and irrational numbers. By the end of this video, you should be able to use the properties of rational and irrational numbers to answer questions about radical operations. So on the top of our notes here, I have just a review of the different kinds of real numbers that we talked about in the previous week: natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So what we're going to do is we are going to add the following rational numbers. So I want you to use a calculator and give me the decimal form. So 5 plus 5 is 10. 5 plus 1/2 is 5.5. So I want you to use your calculator to fill out this chart. Come back when you're finished to see how you did. Alright, so for your chart, you should take a look to see how you did with your numbers. We just want the decimals. Give me several decimal places. So looking, you can see that, let's write this in a different color so it's a little bit easier to see. We have, this is a rational number, 1 is a rational number, 5.5, 5.50. These are all rational numbers. The 0 over here is a rational number, and that 0 is a rational number. All these other numbers, those are all irrational numbers. So that's going to become important when we do our rules on the other side. So now what I want you to do is I want you to do the same thing in this chart, but we're actually multiplying. So if you have numbers here, go ahead and erase those off. So 5 times 5 is 25. 5 times 1/2 is 2.5. So I want you to go through and get the decimal approximation with multiplying these numbers. When you're done, come back to check to see how you did. Alright, so let's take a look. We've got a bunch of rational numbers here. All these zeros are all rational. The integers, -2 and 2, those are rational. Alright, so the purpose of this is we're going to look at some rules, and we're going to go back and refer to these two charts to determine if our answers are rational or irrational. Sometimes they can be both rational or irrational depending on what we pick. So let's flip this over and see what I'm talking about. Alright, so the directions here. Use your answers to the charts to answer the following questions. Your choices are rational, irrational, or can be both rational and irrational. So I want to know the sum of a rational and rational number is. Is it rational, irrational, or it can be both rational and irrational? So the sum of two rational numbers. So let's flip this back and look at the sums. So that's going to be the top chart of rational to rational. So notice I've labeled these rational and rational. So the sum of rational numbers gave us all rational numbers. So the answer to the rule is the sum of a rational and a rational will be rational. Okay, so what I want you to do is I want you to walk through the rest of these, a rational to an irrational. Remember the sum, that's the top chart. The sum is the top chart. The product is the bottom charts. Go and answer these questions and then come back to see how you did. All right, so taking a look, we did the first one together. The sum of a rational and an irrational number is irrational. So when I look at my irrational numbers, adding to my rational numbers, right here are all those answers. None of those are rational. Same over here, my rational with my irrational, none of these are rational, so adding a rational and irrational is irrational. The sum of an irrational number and an irrational number. Okay, let's go take the chart. Look at the chart real quick. It says both, and let's find out why. So when I look at my irrational numbers added to my irrational numbers, twice I had 0 result because they were additive inverses. So they ended up equaling 0, which is a rational number. So usually it's irrational, but in these cases where they're additive inverses, you get a 0 for your answer, making it rational. And that's why the sum of two irrational numbers can be both a rational or an irrational depending on what the numbers were. Alright, so now we're going to be using the bottom chart. The product of a rational number and a rational number is rational. Let's consult the chart to see why. So when I multiply my rational numbers times my rational numbers, these are these answers. Every one of these answers are a rational number. So that's why rational times rational equals a rational number. Now for 5, the product of a rational number and an irrational number, I say is both. So let's see it, look at the chart and see why that's the case. So when I multiply a rational to an irrational, these answers are all irrational, but when I multiplied by 0, all of my answers were rational. So that's how, if I multiply a rational to an irrational, I can end up with some rational numbers and some irrational numbers. So it can be either, both. Now the final one, the product of an irrational number and an irrational number can be both rational and rational. Let's take a look to see why. So when I multiply my irrational numbers times my irrational numbers, you'll see I got some, right here, I got 4 rational answers because I was multiplying a number by itself, making it a perfect square. And so that's why that happened, but the other answers were irrational. So that's why it can be both a rational answer or irrational. It depends on which numbers that you're multiplying together. All right, so here's what I want you to do. I want you to use your calculator to simplify into decimal form and then identify as rational or irrational. Once you have finished, come back and let's see how you did. All right, so 5/7 is a proper fraction, and it actually has a really long repeat cycle, 0.714285, and then it again is 7142857, 7142855. So this is a repeating decimal, which makes it rational. Pi, if you put this into your calculator and it gives you the decimal approximation, pi never stops, 3.14159626. This, and it just goes on. There's no discernible pattern, repeating pattern. They've gone a trillion spaces out, never has a repeating pattern. Irrational. 2 square root 5, when you put it into your calculator, you should get a decimal kind of like this. There's no repeating pattern, so it's irrational. 3 plus 0.25 equals 3.25. That's a rational number. It's a terminating decimal. 8 divided by 3, that's an improper fraction, which gives you 2.666 repeating, so 2.6 with a bar. Repeating decimals are rational. 0.5 times 0 equals 0. 0 is an integer, which makes it rational. Now this one you can put into your calculator to make it do the math for you, but its final answer is 11, which is a whole number, which is rational. Okay, finish the practice for classwork. Turn your answers in on Canvas, and I'll see you in class.